Welcome everybody to Marco Consolaro's talk on Connascence beyond coupling and cohesion. Please welcome the speaker.
Thank you. Thank you. Thank you for inviting me to this beloved conference. And thank you for being here and deciding to share with me the next 45 minutes. I am Marco Consolaro. I work in the software development industry since more than 20 years. And I am the author of Agile Technical Practices Distilled, a book that surprised us in the feedback and the great things they say. So we are actually working to the second edition, so bear with us. And recently I founded Alcor Academy, so now I am a technical coach and a co-founder of a training company. But today I am going to talk to you about connascence. And connascence is a concept that came out in 1995. This book is the book that first mentioned connascence. But for me, the first time I heard about connascence was when I was when I had the luck to work with my friend Pedro Santos, which is here in the room. So we were really focused on software design at that time. We actually were looking for the grand unified theory of software design, and we are still looking for it. But at that time, one day Pedro came to me and was like, hey, have you ever heard about connascence? Oh, no, what is it? So he started to show me some stuff online, and I was like, wow, this thing I've never seen before. I want to learn more. And so I went to YouTube and Googled about connascence. I found this talk by Jim Weirich, he did in 2012. And it was titled, The Grand Unified Theory of Software Design. I was talking about connascence. I was like, wow, there we go. And so I started to look at all these videos. They are fantastic. If you want to know more after this talk, please look at his talks. He was a very great speaker. Unfortunately, he's not anymore with us. He passed away a few years ago, unfortunately. But the problem with this talk is that he was a Ruby developer. So his examples were in Ruby, and so I was like, yeah, I understand the ideas, but maybe I should do something with some code that is a little bit more readable. So, what is connascence about? The term connascence comes from Latin. It's co plus nascence, right? Nascence means to be born, right? And co means together. So the idea of connascence is the birth and growth of two things at the same time. So two or more elements, and this is the difference with coupling, if you want. Field method, classes, parameters, but anything really, are connascent if a change in one element will require also a change in the others. And this is why Kent Beck says, connascence, the concept of connascence is the same of coupling, right? He overlooked on it. But if you dig deep, actually connascence, in my opinion, gives a richer taxonomy than a simple coupling that goes outside the code base. So it has a taxonomy in 3 dimensions. One is the degree. Right? The degree is the size of its impact, right? If something is born together, we can have 2, 3, 4, 5, 10 things that born together. And the number of these things has an impact in its effect. And then it considers also the locality, right? Because if we couple 2 things together, how far are they, right? The locality of this coupling has an impact as well. And then there is the strength, which is derived by the kind of connaissance, because as we will see, we can couple with a lot of things that we don't immediately realize, right? So it's a little bit like this, right? We have a taxonomy in 3 dimensions, and the great things about connaissance is that it gives us a direction for refactoring, right? If we have strong connaissance, we want to keep it back into a weak form of connaissance. If we have things that are connaissant very apart, we want to keep the connaissance close together. And if we have a high number of things that are connaissant, we want to reduce it at a smaller number. I know what you are thinking, right? Show me some code. Otherwise, we are talking about fried air. And so let's see a few examples, and let's get through all the kind of connaissance so you understand more. So let's see this little code snippet, right? This is a simple time class, right? Apparently innocent, right? We set it up with a time, and will just tell us a text representation of the time we set up. And in this little snippet, there's a lot of connaissance of the good kind. That's why I put that quote of Vincent van Gogh, right? In reality, connaissance is the building blocks of what we do all the time. For example, these 3 variables named here, they are born together. They are connaissant, right? If I change one of that, I need to change the other one. Otherwise, it doesn't work. Same for this thing. They are connaissant. But same also the name of the parameters. They are connaissant. And this is connaissance of name. It's a good form of connaissance, and it's the only form of connaissance we should use. And there is another one, very good form of connaissance here. These integers are connaissant. These types are connaissant. If I change the type of the input parameter, I need to change the type of the field, right? Same as this one, and same as this one. And this is called connaissance of type. Now, connaissance of name and type are the very good form of connaissance. We should use only these kind of connaissance. And these are static form of connaissance. They are discoverable at compile time. But there are other kind of connaissance that we put there and we don't always realize. So, for example, let's see a different form of connaissance. Right? This is a notificator class, right? It's something that sends an email. You receive a string as the recipient, another string as the sender, and another string for the message. Right? So, if we want to use it, we need to use it like this. And every time I see something like this, I am confused. My memory is so bad. So I'm like, wait a second. I am sending it to this, or I'm sending it to this, right? I always need to go back and look at the thing, because you never know which one is which. You know? You don't want to send it to the wrong one, right? And so here, what we are doing is essentially giving a meaning to the position of our parameters when we call the method. So the first is the recipient, the second is the sender, and the third is the content, right? But we need to remember this. Right? There's nothing there apart if we have a very good idea, but you know, not every language has something like that. If we don't remember this, we actually don't know. There's an information hiding behind the scene. And this is called connaissance of position. Connaissance of position happens when multiple components must be adjacent or must appear in a particular order. Sometimes they are passed like a structure, like an array of things, where the first element is something, the second is something. This is connaissance of position. How bad is it? Well, not good. It's the strongest kind of static connaissance. And we can solve it, right? That's the thing. We can always try to bring it back to connaissance of name and type. So, for example, let's see how we can fix it. Well, easiest way, we create a type for the recipient. So this is the recipient. Now we cannot get it wrong anymore. You see, recipient, okay, I know. That's it. This is the sender, is where it comes from. Okay, now it's clear, and this is the message, right? We explicit what that is through a type. In fact, we removed connaissance of position using connaissance of name and type. We can do it differently. We can create a notification type, for example, and instantiate it in a fluent manner. Same thing, right? We use connaissance of name and type to solve connaissance of position. So let's see a different one. Right? Let's go on the big kind of connaissance. So let's go back to our time class. Right? This time class is apparently innocent, but what happens if we instantiate it like this? Is this some time? This is a bad time. I have 27. What hour is it? Right? This is no good. This is invalid state. Right? But how do you communicate this problem without the idea of connaissance? Right? The coupling doesn't tell anything about this. Instead, this is by the book example of connaissance of value. Connaissance of value happens when two or more components' values are related or have an intrinsic range of validity in their input not expressed by their primitive types. Right? So, how bad is it? Well, quite bad. Right? It is quite bad. So, how can we fix it? Well, here, right? The idea is that the class should participate in the information flow if and only if its state is valid. So, as a bare minimum, how ugly it looks, we need to validate as soon as we create it. If it's not valid, there we go. There's no way we carry on. Or we can do something better. Right? Can we do something better? Of course. We can actually leverage our type system. If we create some types like this, and then we use these types in our constructor, well, here, see what happened here? We basically make it impossible to create this class with an invalid state. Right? We leverage our type system to create a grammar of what we want to do, so that we don't even need to validate it. Our compiler is going to validate it for us, right? And so also here, we can use connaissance of name and type in order to fix this problem. So let's see another one. And this is something very common in web pages, right? We have a HTML page, which has a drop-down or something, and every value is connected with a meaning, right? Here, then we have a controller in the backend and say, oh, if that is 1, then do this, and so on, right? So here, what are we doing? We are essentially coupling an arbitrary value with some meaning, right? Obviously, this example was done before the pandemic. Right now, no one goes in the office anymore. But you see, number 1 was bike, number 2, car, number 3, train, number 4, bus. Right here, we give a meaning to an arbitrary value. In fact, this is called connaissance of meaning or convention. Connaissance of meaning happens when two or more components must agree to specific values. So we use a convention in order to give meaning to this value. How strong it is not really strong, to be honest. But the thing is that it's very, very easy to fix. Right? It's not a problem at all. How do we fix it? Well, we can declare a constant, and this constant explicit the meaning of those values so that we just use the real name of the constant so that who reads our code knows exactly the meaning of those values. And essentially also here we use connaissance of name and type to get rid to this form of connaissance. Let's see a different one. Let's see a piece of code, right, that do a checksum, for example. And let's see what happens if we implement it like this, right? We have a method to add the checksum, implemented like this. And then we have, obviously, a method to check if the checksum is correct or not. But if we do it like this, we have some repetition here, right? And we code twice the same algorithm into different methods. And this, by the way, is called divergent change code smell. But this is also connaissance of algorithm. And connaissance of algorithm is somewhat connected to the idea of code repetition. In fact, it happens when two or more components must agree on using a particular algorithm, right? Which now is more mathematical, but an algorithm can be also very functional, right? I have to do this, and that, and you repeat the same thing many times. It's still connaissance of algorithm. Connaissance of algorithm is the last one of the static form of connaissance. And also this one is quite simple to fix, right? That's code repetition. It's one of the things that developers understand the most. We just have to encapsulate the algorithm in its own method correctly so that we use connaissance of name and time to get rid to the code duplication. So let's see now the juicy kinds of connaissance. So this is a different code snippet. It's something that sends receipts, right? What's the problem here? The problem is that if, first I have to send to the customer, receipt sender, send, and then I have to archive. If I invert these two calls, this component is going to throw. It will bomb. And this is a very big problem, because I am the developer that needs to use that class, and no one told me that there is an order of the method I have to call. How do you express that in terms of coupling? This is a big problem, right? We are hiding an information that is foundational for the developer in order to code correctly. Well, this is connaissance of execution order. Connaissance of execution order happens when the caller of a component must have some unexpressed knowledge about the order of the methods to be called. Right? How bad it is? Well, it's decently bad. It's a dynamic form of connaissance. And it has very clear examples, right? For example, builder pattern. Okay? The builder pattern is an example of connaissance of the execution order, right? Because first, we need to set up the builder. And then, we need to call build in order to have the concrete with the things that we set up before. This is connaissance of execution order expressed by convention. Well, now, here it is mitigated in the builder pattern because it is a pattern. We know how to use it because, it's a builder We know that that builder pattern works like this. First we set up, then we call it, right? But what if we want to make it explicit? Can we do better, right? What if we want to force our programmer to have a particular sequence of method calls without him to guess how it works, right? So let's see how we can do that. We can start segregating the interface. We can create a few interfaces like this. So I have a iBuild card with brand, which wants a brand and then returns an iBuild card with engine, which expect an engine and then return a iBuild card with color, which then finally give me the builder that will return my concrete, right? If we want to do the builder, we now inherit. Actually, we are implementing all these interfaces. The concrete is the same. We are just segregating the interface. But we just add a factory method so that we force the builder to return the interface we want to start with. And so if we want to use it, now we can do, new. That's because with brand, he wants a brand. Now we can't just set up a brand. And then we have to set up the engine. And then we have to set up the color. And then we finally can build our concrete. We remove connaissance of execution order using connaissance of name and type. So let's see a different one. I have a nice piece of code. Who can tell me what is really bad in this piece of code? Thread slip, right? Why is it bad? Yeah, how do you call it? Connaissance of timing, right? The thing is that with coupling, you can't express why this is bad. Right? Here we are coupling with the concept of time. Right? We are not in control of time. So it's very, very risky to couple with time. And this is a concept, a word that is very useful to pinpoint exactly this problem. And without connaissance, we don't have a word for this thing. That's why I believe connaissance is a very, very good toolbox to have when we do software design. I'm not sure if it is the grand unified theory. I don't go so far. But definitely, it's very, very helpful in many occasions. So connaissance of timing happens when the success of two or more calls depend on the timing when they occur. And this is quite strong. It goes there on 7th place. And it is not easy to fix, right? Because sometimes we have to couple to time, right? So how do we fix it? Well, this is an example of how I mitigate this problem. And this is very close to production code. I was working on these ones. And essentially, we had to wait 1 second because we were testing something that were connected with the messaging system. So we needed to wait in order to make sure the message arrived before we run the test. So here, the best way to solve this is to actually redesign our tests. We don't need to pass through the infrastructure in order to test the logic of our app. We can go under the skin, and then all these tests are decoupled from the infrastructure. And that means that we don't care about time anymore. But in that team, the system was already set up like this. Doing something like that was unthinkable because it would take months. And so what I did, I actually added an event. Now, fortunately, this is C# code, so the C# offers the event system embedded in the types. That is very, very handy. Here, in our test, I essentially set up an event that would be raised if the message arrived. So in our test, I put a semaphore that was waiting for that event, and if the event arrived, it didn't wait for 1 second. In the happy path, it just went on as soon as a message arrived. And this event was only attached in the test. So in our production code, this event had no listener. So there was no effect at all in our production code. And this saved minutes every time we run the test. Because every test, even in the happy path, was waiting 1 second. And, 1 second, it's easy to wait minutes for our acceptance test. But I don't have minutes for my acceptance test. Maybe I have seconds, very little seconds. And so through this way, we could actually solve that problem for all the happy path. Of course, the unhappy path was still there because the unhappy path had to wait until the timeout for the message happened, and then check that the unhappy thing happened. But there were very few tests about the unhappy path, and a lot of tests for the happy path. So it was very, very relevant at the end. And another way to do that, sorry, let's go back. Another way to solve or mitigate this problem is to parameterize the amount of the timeout. That's another thing we discovered recently. So basically, if you really have to test a time dependency, and for example, in production, it needs to be 3 seconds, what you can do is isolate that module and parameterize the timing. So you can actually test in your tests using milliseconds, and that makes the test really fast. Even 100 milliseconds and 150 milliseconds can be enough to test that before and after happen what you expect to do. But then in production, you parameterize with the value that the production wants. So you can actually still test the timing with very, very small amounts, but without having to wait minutes at the end for the test suite to run. So here is another kind of connaissance, very bad. Unfortunately, we don't see that anymore. This is something that in the 90s was more popular, right? This is a singleton anti-pattern, right? And it works only if we pass the exact instance to all the controllers, right? This is called connaissance of identity. Fortunately, we don't see too much of this now. We have distributed things, so singletons are less common, thanks God. And it happens when one or more components must agree about the exact particular instance of another entity. And this is something that goes straight at the top. This was the kind of connaissance that were in the book of Bailey Page Jones. But then, while working with Pedro in a different place, but still together with him, something happened one day, and I realized that there was one kind of connaissance missing, right? So I was in the team where I solved the connaissance of timing, right, with messaging. And so we had to do a task. We had to implement and handle a couple of more messages. We had to handle a different message and spit out 2 different new messages. So I implemented all that stuff. That's why I went through this problem. I was like, how can we wait so much for this? And I solved it. And I code, I refactor a little bit, I code the thing. And in my machine, the new events were perfect. They worked fine. Everything was fine. We were all happy. We did a lot of pair programming, so everybody in the team was involved. We did teamwork. It was perfect. We push it, and then they continue integration. Bam. Everything fell down. And there were more expert people in the team of the domain, right? They were there since years. They knew all this infrastructure. So I was like, what's going on here? And they were like, strange, it should work. Yeah, I know it should work, but yeah, if you don't know what can possibly be, to me, yeah, it works in my machine, it goes in continuous integration, it should work exactly in my machine, right? And so they were thinking and thinking, right? Until after a few hours, the most seasoned folk in the team was like, oh, I remember now, I remember. You remember what? Every time we had an event in our code, we need to instruct the build script that there is a new event. I was like, what? So every time we touch our code, we need to go and fidget with scripts around. Why is not able to carry on independently? Right? Oh no, but because otherwise we never touch the building script, so we can refresh our knowledge of the scripts. Yeah, are you crazy, huh? If you have to do dozens of events, what do? You go crazy. You don't even know where it is. I was like, this is full, right? We are actually automating stuff for others, but then we accept to don't automate the stuff for ourselves. It's like nonsense for me, right? And actually, what I realized is that this is a new form of connaissance, right? And in our book, we added this form of connaissance, which is connaissance of manual task, which happen when expanding the functionality of our code require touching things outside our code. Right? And for us, this is the real worst kind of connaissance. So, add enough manual tasks, and Tim will spend more time trying to make things work than writing well-designed code. Who said so? Myself. Sometimes I like to quote myself. So I close. It's all about design. It's the mantra of Pedro. And I agree. So once upon a time, Claude Shannon, the discoverer of entropy in communication systems, said, we know the past, but cannot control it. We control the future, but cannot know it. Which is debatable. I know, I don't want to go in the philosophical side of it, because in software development, it's not really true. We can change the past in software development. It's called refactoring. But if you want to do effective refactoring, as Matthias said in the keynote today, right, you need a good design. Because in the long term, if you have a good design, you can do way more refactoring. You can refactor more often. You can continuously refactor for the better. If you have a bad design, it's really hard to understand what you have to do when you do refactoring. And you always do refactoring when it's almost too late. You do it because you are entangled. And then you do a big refactoring to entangle some stuff. You carry on for a long while. And then, again, you go in a point where you need to do some refactoring. But it's too late. You can't understand much. So it's always less effective until you get stuck. Well, if you have a good design, maybe in the beginning, you are not as fast as the other because they cut corners. And so in the beginning, it seems they are flying. And instead, you are not. You are there with the working skeleton. You are doing your thing, try different possible solution for your domain model. Right? In the beginning, it seems that you are the slow one and they are the fast one. But it doesn't take long when the things start to change. And then in the long run, we actually allow ourselves for breakthrough. And when you have the real breakthrough, actually, you become super fast. So in the long term, you are the one that fly, and they are the one that stop. That's how it is, in my experience. So how do we do that? Well, in my mind, we have different tools that can help. And they apparently seem different. They apparently seem detached, different things. But the reality is that they are just different gauges for the same things behind the scene. We have things that help to understand if our code we have already there is good or not, because we are not perfect. Like first you try, and then you need to be critical, have critical thinking about your code, and through this method, say, wait a second, we coupled too much here, we can maybe decouple this. And so this helps you to analyze the past and improve what you already do. But we have also principles that push us to go in the right way when we code for the first time something in the future. It's always, we try to go in the right way, then we stop, we criticize it, and then we fix it, and then we carry on. It's always forward and back in order to keep our design as good as we can. And for example, it doesn't matter which one of these codes you use, because as far as you have one that tells you the problem, and then you can spike a solution, like magic, all the problems disappear. So for example, how many problems we have in this piece of code, right? Well, long parameter list, right? Integer, integer, and array of integer, nice. Right? This is connascence of position, right? Long parameter list code smell. Then we have no single responsibility because it generates the order ID as well. Why this class generate the order ID, right? Then we have low cohesion. And then it processes the order, passing all those bunch of integers, right? That's data coupling in terms of coupling, but it is also primitive accession and data clamp in terms of code smells. Right? We have different things that tell us the same problem. So here, let's fix connascence of position. Right? So we encapsulate the order in its own class, and now this order flow looks much better, right? We use connascence of name and type to solve all these problems at once. Here, the idea, what I claim, is that all these tools are actually influencing each other. Coupling influences cohesion, which influences connascence, and so on. And what I claim is that what we are doing, we are trying to minimize the entropy of our systems. And connascence, coupling, cohesion, code smell, they are all tools that give us alarms about the entropy raising in our system. Because entropy is the degree of disorder in a system. There's many different definitions, but I really like this one because it makes it clear that if we don't tame it, it tends to grow, right? And here the idea is that entropy is a probabilistic concept. So if we have a system that has a lot of possible states and only a few are valid, here we augment the risk that the wrong state happen. And this is the idea of entropy. And this is why a bad design at a certain point doesn't allow us to touch the code almost anymore. Because the possible unwanted state is so big that it has a combinatorial explosion. And when you reach that point, every time you add a new state, you have an explosion of possibilities. It becomes really, really hard to tame the fact that the system can go in a wrong state. So, I close. Do you know who is him? Alan Kay, father of object-oriented programming. Once upon a time, he said, you can write COBOL in any language. And people do that all the time. So please, 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 don't be that people. We are trying to help in our Lido, and we wrote this book that is going to help with software design. We received some amazing awards, and for KanDDDinsky, there is a 50% off in LeanPub. We are working to the new edition, but if you buy the LeanPub edition, when the new one comes out, you will get it for free. So this is a little present for you here and for KanDDDinsky. And of course, if your company has a big budget and you really want to go the next level, that way you can take picture of this. I'll let you a few seconds. How much do we have left? Can we do Q&A or?
10 minutes.
Oh yeah, cool. Okay, so if you want to go the next level, your company has a big budget or likes to do training and likes to do very high quality training, we have our training program with Alcor Academy, where we help leaders to promote a culture of excellence with an innovative socio-technical training with more programming, where we do all these things. And actually, this is one of the lessons, is the theory of one of the lessons. Now, in our training, we will have the exercise about this. So it's going to take too much. I cannot do it today, but maybe one day we do a workshop about that. So if you want, you can contact me there. And that's it. Thank you. If you have questions, yep.
I wanted to ask if the concept of connaissance, do you use it only for code, or would you also use it for more infrastructure things? Like, I'm just thinking, for instance, the choice of putting all of your data in the same database, even though it's very diverse and so on, because this is how you start.
No, because this is how you started, it's not a very good heuristic, in my opinion. Well, let's say that is a concept of coupling, right? Yep.
Please repeat the question for the recording.
They repeat the question. Do you have a mic for the?
Okay, the question is, does the concept of connaissance apply also to things like infrastructure and, for instance, as an example, storing all the data, diverse different types of data in one database?
Because we have always done like that. And that is a bad heuristic. I think that this is where I agree with Ken Beck, right? The concept of connaissance is related to coupling. And that is a coupling at a high level. So we are coupling to the database even if we shouldn't or we don't have to. But since we are lazy, it's like, well, yeah, let's throw it there. So it's a matter of laziness to me. It's a coincidental choice that comes because we are too lazy to think the best solution and then implement it, right? It's easier to say, let's throw there. We can survive like this for a few years, maybe, if we are lucky, fingers crossed. Probably is that when you hit the point you are not surviving anymore, and then I want to see you fix the solution. It's better to fix it in the beginning when the system is still small. Other question? Microphone, maybe?
Thank you. So it was really nice getting to know this topic, connaissance. But at the same time, for example, suppose if you have a very old legacy system, right, where you have every possible thing which you just described, which is just there, like you cannot do anything of it. It's working, everything is doing great, business is working fine. And in those scenarios, for example, if the business wants to introduce a new change, and as a developers, how can we be so sure and how can we avoid this going further? Because for me, I think it's not possible. There are scenarios it's not possible to get rid of this, even though you think that you can improve on it. It's not possible. How do you propose that we can handle such situations?
Legacy code is a different beast, right? And we actually have an advanced module supposedly for legacy code. And legacy code, does it have tests?
Yes and no.
And so it's no, right? And so first of all, we need to put the tests in place. And that's where we start with the paradox of legacy code, right? We need to put tests in place, but we should not change the code until we have tests in place. But to put the test in place, we need to change the code. And so how do we do that? Yeah, it's a paradox. And so here the idea is to learn some techniques that allows you to plug in tests in situations where apparently is impossible. There are a lot of techniques. Michael Fader's book, Working Effectively with Legacy Code, is amazing about that. It's not an easy book, but if you grasp the idea there, you can actually act on any really bad legacy code to add the test. And once you have the test, and then you can tackle the design and are sure that you don't have side effects. But first you need to put a test, then you need to have the characterization test, you need to make sure that the tests are actually correct, so you may want to do mutation tests, and then you can actually refactor the design and maybe also improve the tests. So yeah, it takes a lot of time to fix it. It's possible, but it is a process that starts very, very far away. And so sometimes you don't have that time and you have to do the change and pray, like, don't remember who was that says, right, software is like building cathedrals. First we build it and then we pray. If the time is over, we can go out. No problem. Okay, there's another one there.
Hi, so when you showed different kind of connascence, I can really see that there are many patterns that you can observe in the code. But as a developer and with the pressure to deliver, you cannot keep track of all those things in the code. Have you came across any kind of tooling which allows you to really highlight those kind of problems in your code in an automated fashion so that it relies less on manual intervention and more in automated fashion?
I've heard this question before, and the thing that the only kind of connascence you can discover with a tool is the static kind of connascence, which are a little bit not very juicy kind, right? Those are easy to spot even with the eyes. Right? The problem is when we have connascence of timing, connascence of value, connascence of the execution order. Those are the three kind of connascence that might be overlooked. And then when a developer tries to use your thing, it doesn't understand why it doesn't work in the way you try. And there's no way you can have a tool to discover that. And I tell you more, even the connascence of time, the connascence of type, in JavaScript or not type languages goes up in the dynamic form. So even then, that's why it's harder to code in those kind of languages, because even the type moves up in the dynamic form. No more questions? Okay, so thank you.